In this video, we're going to look at how to change a slider in Desmos into a list in Desmos. We're going to investigate a parabola, really a whole bunch of parabolas, and try to figure out some features about the standard form of a parabola. So to do so, we're going to start with putting in the equation for a parabola. Let's put it in standard form, and let's give it the name f, so we can refer back to it later if we want. So I'm going to say ax squared plus bx plus c, and then since Desmos doesn't know what it wants, we want a, b, and c to be, we're going to say add sliders. You may have played with sliders already. It's a really nice way to figure out what's going on. So if we play with some sliders, a is pretty straightforward. The higher a gets in the positive direction, the more steep the parabola becomes. Likewise, in the negative way, now it's face downward, and the more steep it becomes. And if a is a really small number, then it's a pretty flat parabola. So that's a. That's how a changes the shape in standard form. C is also pretty straightforward. C is the y-intercept, and we can actually show that by clicking on the y-intercept and seeing how it maps directly. So negative 4.3, and our c value here is negative 4.3. And as we change that, it's a one-to-one relationship. It's sort of nice and straightforward. What we're going to look at, we're going to try to investigate, is what's happening with b. So as I drag b around, b is certainly doing something to the graph. It's not changing the shape, and it's not changing the y-intercept, but it's changing the graph in maybe an unexpected way. It looks like if we look at the vertex, we can click on it. We can move that around and try to see what's happening here. The coordinates might be a little bit distracting. So what we're going to do instead is we know how to take that vertex and figure out what the vertex is. Since this is a parabola, we know a lot of stuff about parabolas. So the x value for the vertex is negative b over 2a. So that d value represents the x value for the vertex. And so to get that coordinate to show up, since I called it f, I can refer back to it later. I just enter in the coordinate d, f of d. So now I have that vertex always being highlighted. So I'm looking at just the vertex. I'm trying to figure out what's going on with that vertex, how it's moving. It's definitely moving from left to right, but in the opposite way maybe you'd think. As b gets larger, it's moving to the left. As b gets smaller, in the negative direction at least, it's moving to the right. So it's moving opposite, and that's probably because of that opposite, the negative sign in the vertex. But it's also moving up and down in an interesting way. So to investigate this, what we can do is, I have a whole bunch. As I drag this slider, I have a whole bunch of parabolas being graphed, but only one is being shown at a time. So what lists allow us to do, lists allow us to graph a whole bunch of parabolas all at the same time without having to worry about a slider. So to change this slider into a list, all we have to do is put in a square bracket. And let's say we want the list to have values 1, 2, and 3. And so if I do that, it's a 3-element list. So you'll see that when I have a 3-element list, it's actually graphing the parabola for all 3 of those list values, 1, 2, and 3. So b value of 1, there's our first graph. B value of 2, here's our second graph. B value of 3, there's our third graph. And we have some stuff going on. And so it sure be nice to go from, I don't know, like negative 10 to positive 10. So I can put in negative 10 and then comma negative 9, comma negative 8. This seems a little repetitive to type in all the way to positive 10. The really nice thing is it assumes if you go comma and you put ellipsis in, dot, 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 you put the last value in, it's assuming that you have an arithmetic list, arithmetic sequence. So now, since I've gone from negative 10 to negative 9 and I've added 1, it's really going to add 1 all the way to get to positive 10. So I can actually make this list a little bit more simple to represent. So negative 10, negative 9, and it's going to add 1 to negative 9 to get negative 8. Negative 7 goes all the way to positive 10. So then there's 21 elements there. I actually have 21 parabolas being graphed at once. And if I zoom out a little bit, can see what's happening. So that's really sort of a pretty graph. It's sort of neat. And now I can look at just the vertexes. I can turn the parabolas off and just look at the vertexes and get an idea what is happening with different b values. What shape of a graph is that vertex creating as we make a whole bunch of those graphs? And we can be even fancier. Instead of adding 1, -10, add 1 to get -9, I can add a smaller value to get more parabolas. I can add 0.5. So I can go -10 plus 0.5 is -9.5. Now I have twice as many. I have 41 lists. I can add 0.25. 81. I can add a whole bunch. I can add, let's say, 1/10. So I'm going to get a 200. So this represents 200 different parabolas being drawn. These are the vertexes of 200 different parabolas between -10 and +10, and we can turn those parabolas back on and see what we get as a graph. It's going to take a little bit of time. That's 200 parabolas being drawn at the same time. It's pretty fancy. It's not bad. So that's what a list does. The list allows you to represent a whole bunch of different things all at once with one variable. So that variable actually represents 21 different values. Now that I've changed it back, it represents 21 different values. So there's 21 parabolas being drawn. And so when I take that parabola off, then those are the 21 different vertexes for those 21 different parabolas. And now I might have a better idea what is being changed. Now when I can change my sliders for A, and I can actually see how that may or may not change where those vertexes will end up after I've changed things. So I don't even have the parabolas drawn anymore. I just have the vertexes of the parabolas drawn. And that B value can represent that. So that was a little demo on what a list can do. It can make some really pretty graphs, but it can also help you investigate what's happening with functions.